So today's topic is, let me just move this one. So today's topic is join subqueries and views. So we are in third week. So let's get started with the presentation. So the topic we are going to cover include joins, and we'll talk about table relationship with primary key and foreign keys. And we'll see the concept of union, subquery, and view. So let's start with a join. So join basically combines records from two or more tables to produce a result set. So join is a means for combining fields from two tables, for example, by using values common to each. So the way that you can specify a common values is using where clause, and we're going to see that in a few seconds. And these joined tables are typically related with foreign keys. There are four different types of joins: cross join, inner join, and outer join, and self join. In most cases, you are dealing with either inner join and outer join, and more likely with inner join. So let's talk about the cross join. Cross join matches each row from one table to every row from the another table. So it actually basically creates Cartesian product, and of course is very costly in terms of CPU time. And basically, if you happen to have 1,000 records in table A and another 1,000 records in table B, the Cartesian product will result in 1,000 times by 1,000 times, which result in 1 million records in a result set. So it's rarely used in production environment. By the way, cross join is a default. So if you don't specify how to join rows from different table, the database server will assume you want cross join. So these are examples. So there are two different ways that you can have a cross join. So typically when you say select, and this is the name of the column, and here I just want to actually get ename field from employee table and salary from employee table and dname from a department table. And here you say from employees and departments, two tables with a comma. And here we use the alias. So this one, because you haven't specified anything, it assumes that you want cross join. Now, if you want explicitly specify you want cross join, you can say cross join like this. So from employees and cross join and departments as a second table. Okay, so suppose we have these two test tables. One is department and the department number 1, 2, 3, 4, and these are department number names with the column name dname. And these are employees table, and we have employee name and department ID. This is the foreign key field pointing to department. Pointing to department table, and these are 1, 2, 1, 2, 3. These are the values from department ID, the primary key field from departments table, and then salary field. So let's say we have these two test tables. So if we actually want cross-join result set, basically it will result in 24 rows. So 6 times, so basically 4 times 6. So it will result in 24 rows. Okay, so that is cross-join. Now let's move on to inner join. So inner join, as I said, is the most popular type of join. And among the inner join, the most common type of inner join is what is called the equijoin, where certain fields of the join tables are equated to each other using equality operator. Now, inner join requires a match in each table. So that match condition is again specified in where clause, which we are going to see in a second. By the way, rows that do not match are excluded from the result set. And as you will see later on, this is the difference from outer join. Okay. All right, so let's see examples. So by the way, there are 4 different ways that you can specify inner join. So here we say select and the fields from these two tables and then we say from the names of the first table and the second table, and then we basically specify the equality condition using where clause. So here, department number specified in the employees table is the same as department number of department ID of departments table. So basically what you want to do is I want to display all the employee and this information, these three fields from these two tables, where the employee who has a department ID. So you do not want to display employees who do not have department ID assigned yet. Okay. All right, so we'll see that example in the following slide. So this is another way that you can use inner join. So here you say from employees, and then you specify join and the same where clause. Here you can also specify inner join as well. Okay, so this is the same thing as this, and instead of using where, you can also specify on. Okay. So this is probably the most common form of inner join example you probably see, the most simplest way. All right, so if you display inner join result set, you are going to see this 5 because we are going to see the e-name, salary, and d-name. And basically what you want to display is all the employees who has department ID assigned. Okay. So from the 6 people, if you remember the test table, we have a test table that contains new person who do not has the department ID assigned. So that's the reason we don't see this new person in the result set. Okay. All right. So we see these 5 records in the result set. So that's inner join. Outer join, the all records from one side of the join are included in the result set, regardless of the fact that whether they have a matched records in other side of the join, meaning in the second table. So as I said, this is the difference from inner join. Now, depending on which table you want to include, which side actually the join is included, you can have left join or right join. So outer join basically can be either left join or right join, depending on which side of the join will be included. So left join, all records of the table on the left side of the join will be included. That's left join. Right join is the other side. All records of the table on the right side of the join will be included. Okay, so let's see example of this. So the way that you can specify the outer left join is basically you say left join. Okay, so when you say left join, that means outer left join. Okay, so here the employee is the left side, right? So all the employees, regardless whether that employee has a matching the department ID in department table or not. Okay. So the result is going to be like this. So we have the employee who do not have the matching employee ID, department ID is included in the result set because we actually chose a left join. Okay, so all records of the employee tables are included in the result set regardless of the match because employee table is the left side of the outer left join. Okay. On the other hand, if you want to do right join, outer right join, basically you say right out join. So all the records in the right side of the join, outer join, will be included, and that's the department. Okay. So in this case, we are going to see, you see actually department ID here. Okay. So this is the employee name, salary, and department name. There is actually no one that is assigned to department HR, but still is included. Okay, because we chose right join, outer right join. So every record in the right side of the join, which is actually in this case departments, will be included in the result set. Okay, so let's start our first demo. So let's go to our lab documentation. So this is exercise 1. So we are going to set things up. So, you want to move on to your MySQL underscore join hands-on lab, the root directory. Okay, so which I've done already. And then we're going to start the MySQL shell. MySQL -u root -p and no password. And you have to specify what database you want to use as a default database. So we are going to still use MyDB. Okay, so database has changed. Okay, and so this is the join table, the exercise. So first of all, we are going to create a department table, and then we're going to create the employees table. So those are the same tables that you have seen in the slide. And then we inserted those 4 departments. And then we have inserted 6 employees record. Okay, so you can see new person doesn't have department ID assigned. Okay, so let's run the file using source command. Okay, so if you want to see departments, select stop from department. So we got 4 departments, and employees, we are going to see 6 of them. Okay, so again, you see new person doesn't have a department ID assigned. All right, so we are going to try cross join. So you can certainly find out the join command information by just typing help join. Okay. All right, so we are going to try cross join. So here we are going to try both formats. So here, this is a default. Okay. And here we are going to specify the cross join explicitly. So that's cross join SQL file. So we are going to see the result of it. So as expected, we see 24 records in the result set in both cases. Okay, all right. Inner join. So as we learned, there are 4 different ways that you can specify inner join. Okay, and if we run the inner join as expected, we'll see 5. Oops. Okay, so we have 4 different inner join syntax. So you can see all 5. So there is no record that do not have a matching the records between these 2 tables. Okay, so 5 employees. Okay, so that's inner join. And outer join, we are going to try left join and outer join. So in these 2 cases, the tables on the left side is employees and then we are trying right join. In this case, the department employees. You will see actually the same result between this and this. Okay, because this is the left join and this is right join, but we just changed the department. So this time we have a department on the left side and employees on the right side. So this one should have the same result as this one. Okay, same thing with this one. So this one should have the same result as this one. Okay, the left join and right join is the switched and the tables are switched. So that should actually work in the same way. And so this is the the outer join. Okay. Yeah, right. Yeah, we basically use the outer, the explicitly. Okay. All right. So let's try that. Okay. So as you can see, depending on which table is included, you can see that this is one. There are, in fact, this is the employees is on the left side and it's a left join. So all the employee records are there, regardless whether it has a matching the department or not. Okay. So this is a case that in this case is the right join. So all the departments are included. meaning all the department records are included, regardless whether it has any matching employee or not. Okay, and as you can see, this one should have the same result as a third. Okay, because as I said before, the left and right tables are exchanged while the left and right joins are also exchanged. All right, so moving forward. Self-join is something I have not explained. It's basically you are using a same table for joining. So in this case, I'm actually self-joining, the and getting the e-name and salary information from employees as E1 and employees as E2. Okay. So in this case, we're going to actually see 36 rows. Okay, because it's 6 records by 6 records. Okay. So let's try that. Yeah, self-joining is rarely used, but it's okay. 36 rows in a set. All right, so let's move on to the next topic. So table relationships are basically constructed through the use of primary key and foreign key. So as we learned last week, week before, primary key is a field or a combination of fields that uniquely identify a record in a table. And foreign key, sometimes referenced as a referencing key, is a key that is used to link the two tables together. And you are going to typically take the primary key field of one table and insert it into another table, and that table, that column where the primary key of the first table is included becomes a foreign key column. All right, so this is an example. So we have departments table here, and department has a department ID as a primary key as specified here. Okay, and then we have employees table, employees table, which has its own primary key, and then it has a foreign key column, D underscore ID, and the foreign key is specified with this. So foreign key, the name of the column, okay, and that's DID in this case, and it references department, the table name, and table's primary key field. Okay, so this is the way you can specify which column of your table is in fact a foreign key, and which primary key field of which table is specified with this departments table and department ID. Okay. All right. Table relationship. Types of relationship. There could be one-to-one relationship, or it could be one-to-many, or it could be many-to-many. So one-to-one many relationship means a person, in this, for example, a person has one primary address. Okay, so that is one-to-one matching between person record and the primary address record. And so person table has a one-to-one relationship with the primary address table, and the primary address field has a foreign key field referring to the primary key field of the person table. So this is an example. So we have a person table and a person ID, which is a primary key field. And then we have primary address table, which specify a column, PID here. This PID foreign key column references the person ID primary key field of person table. Okay. Okay, so if you construct, if you actually put some the data into these two tables, and you probably see you're going to see PID column, which contains primary key values of this person table. Okay, so this address belongs to this person, this address belongs to this person, this address belongs to this person, and so on. Okay, one-to-many relationship, on the other hand, has that one table has so probably it's easier to explain in an example. A department has many employees, and employee belongs to only a single department. So in this case, department and employee has one-to-many or one-to-n relationship. Okay. So in this case, employee table has a foreign key field referring to the primary key field of the departments table. Okay, so let's see an example. So again, this is the departments table, and then this is employees table, and employees table has a DID which references departments tables department ID. Okay, so this is an example. So this is a foreign key field of the employees table, which references to department ID primary key field of the department